Hello friend, welcome back. Here we'll see like how the histogram works, and I have some PDF manuals and try to read that. Like it says, like in order to estimate the selectivity, or in other words, come up with the optimal execution plan, CBO, which is like cost-based optimizer, takes various inputs in the form of statistics, configuration parameters, etc. From the table column perspective. CBO collects the following statistics: number of distinct values in a column, low and high value of a column, number of nulls in a column, data distribution, or histogram information. So let's take an example of a table having 10,000 rows and two columns. Column all underscore distinct contains distinct rows ranging from 1 to 1000. Column skew has values 1 to 10 for first 10 rows and value 1000 for rest of the record, that is like 990 rows. Okay, so we are going to create a table in which we will have two columns. One is like all underscore distincts that will contain 1 to 10,000 unique values, and then we have a column skew in which the first two rows values will be 1 to 10 and 10,000 for rest of the distinct. Okay, so let's go by this. So what we are trying to do, create table histogram as select row num all distinct underscore 1000 skew from dual connect by label this thing. Okay, let's see. Then let's try to describe this table. All underscore distinct is this. Then let's see how we select count asterisk from histogram, which is like 10,000 value. Now what we are trying to do, we are going to update histogram set skew is equal to all distinct where row num is less than is equal to 10. Okay, so train rows committed commit. Let's see, select asterisk from histogram where row num is less than 10. Okay, so if I go row num less than 20, let's see what the values are. So you can see for till the 10 value we have it's all equal to all distinct. So what we used, update histogram set skew is equal to all distinct where row num is less than equal to 10. So we have made the first two rows same as this, but the rest of the rows having the constant value. Now we are going to do select skew count asterisk group by skew order by skew. Okay, so what it will give us the count of the distinct values present in the skew column in the histogram tables. Okay, so let's see. So you can see like I have value from 1 to 10 in a skew, and these are the counts, self-explanatory. Now we are going to gather the stats. So before I press enter here, let me paste it. So what we are doing execute dvms underscore stats dot gather table stats user histogram method opt all for all column size 1. So we are gathering the table stats in the current user. The table name is histogram method underscore opt for all column size 1. So when we use this method underscore opt, we are actually calculating the histograms. Okay, let me press enter here. So it got calculated. Now let's try to run this query. So what is this going to do? Select column name, num of distinct, density from user tape call statistics where table name is histogram. So whatever we capture the stats here, that values will be restored here. Let's try to see it. Okay, so we got this value. Okay, set lines is equal to 1000, set pages is equal to 1000, and then run this. Okay, so let me scroll up here, and I have the number of distinct value as 10,011 for skew and all distinct. Okay, so the density statistics for a column represent its selectivity, that is calculated as 1 / number of if no histogram is present for a column. In case of a histogram, density calculation depends on type of histogram and Oracle version. Okay, now let's see the plan. Okay, for this select asterisk from, so this has not actually executed. but I will explain dvms underscore explain dot display. Okay, so this is what the optimizer thinks. If I actually run select asterisk from histogram where skew is equal to 1, it will follow this particular way of representing the explain plan. Okay, now so it's doing. So again, if I change my values here, explain plan for select asterisk from histogram where skew is equal to 10,000. Now let's do select asterisk from table dvms underscore explain dot display. Okay, so I'm getting the table access full again here for a skew value of 10,000. Now so it says optimizer would use a suboptimal plan if we create an index on a skew and use it with a predict value of 10,000. So let's try to create index skew underscore on the histograms. Okay, so we created this. Now let's try to gather the stats. So what we are trying to gather, so we are trying to gather execute dvms underscore stats dot gather underscore index underscore stats user skew index. Okay, so this will gather the index stats. Now let's try to run this explain plan for select asterisk from histogram where skew is equal to 10,000. Let's see, is it the same? Yes. Select asterisk from table dvms underscore explain plan dot display. Okay, I think this will give error, so let's try select asterisk from table dvms underscore explain dot display. Okay, so now we see that it's using an index range scan. Okay, there is a change in cost? Yes, the overall cost is 4. Here it was 7 when it was trying to do this thing. Okay, so it's doing table access by index row id batched histogram. So we understand that without giving additional inputs, CBU assumes, so it's still not using the histograms which we have gathered. So let's see what's okay. Now we are going to gather the stats. Now let's create a frequency histogram for a column skew and see how data is stored in data dictionary. We will see the different options available for creating histogram in a latest section. For the time being, let's understand that method underscore opt for column underscore name underscore name creates histogram for the column underscore name with n number of buckets. Okay, so this 1 and an 11, or basically this one, defines how many buckets we want to create. And how do we are taking this call? We are taking this call based on this one. So we wanted to create an 11 buckets based on the distinct value. So let's try to, and that's an interesting finding. Okay, so this got created. Now we are going to see column name, endpoint number, endpoint value from user tab histogram where table name is histogram and column name is skew. So we are going to get 11 buckets for this, and let's try to try to DSC histogram, and instead of skew I should put all distincts, and let's see how many buckets we have. So we have just 2 of the buckets. Okay, did we calculated okay, let's what I'm trying to see, did we calculated any histograms? Okay, we did this. Okay, so here what we do for all columns, so the columns was not specifically defined, but here we did for column skew, for instead of all columns, for only column skews. Okay, And for all columns there are two buckets here for all distinct. Let's see. The first statement, create histogram for column name skew with the 11 buckets, since we know that there are 11 distinct values for skew. The endpoint value shows the actual column value, and the endpoint underscore number shows the cumulative number of rows, or in other words, cumulative frequency. For example, for endpoint underscore value 5, what we have it here. Let's see. Okay, let me try to call column name format A20, and let me try to run this. Okay, so the endpoint number is 1 2 3 4 5 6 9, and endpoint value is like this. So what it says, the endpoint underscore value shows the actual column value, and the endpoint number shows the cumulative number of rows, or in other words, cumulative frequency. For example, for endpoint underscore value 5, we have endpoint number as 5 and the previous endpoint number is 4. Hence, the number of rows with value 5 is 1. Similarly, for endpoint value 10,000, its endpoint number is 10,000 and the previous bucket endpoint number is 10. So, the number of rows with the value 1000 would be 10,000 minus 10. Validate by executing this. So, let's try to validate this. Okay. So, what it does, select endpoint value as column value, endpoint number as a cumulative frequency, endpoint number minus lag. Okay, so we are running this query just to find the frequency. So we see it like that way. Okay, now let's see. We run again this thing. We are going to calculate density histogram from tab stats, and we know like density is 0.005, frequency is, histogram is like a frequency, and we are going to do an explain plan here for this, and we are going to display it. Select asterisk from table dbms underscore explain dot display. Okay, so we again got table access full for this particular table, and okay, let's see. We go this explain plan for skew, select asterisk from table dbms underscore explain dot display. Okay, so we see it's using an index range skew id, skew underscore idx, table access row id. Okay, so now Optimizer is precisely calculating the cardinality of 9900 rows, and due to this calculation, now Optimizer is choosing full table scan for predictive skew equal to 10. Also, that density values change from, which is like 1 by 2 into num of rows, or 0.5 by number of rows. Okay, that is the density. Height balance histogram. In height balance histogram, there will be a more distinct values than the number of buckets. Oracle first sort the column data, and then complete data set is divided into number of buckets, and all buckets contain the same number of values except the last bucket that may have a fewer values than the other bucket. There is no separate statement to create high balance histograms. When the number of buckets requested is less than the number of distinct values in a column, Oracle creates height balance histogram, and the meaning of endpoint underscore value and endpoint number are quite different. Let's create a histogram on a column, so this time the number less than the actual number. Okay, so we are going to reduce the number of bucket here, which is 5 in this case. Let's do this, select which is like this, 5. Execute dbms underscore stats, gather table stats, user histogram method of for column skew size 5. Then select bucket number 1 2 3 5, endpoint value is like this. Okay, bucket number 1 has the endpoint as 10,000, 2 has the 10,000. The highest value in each bucket is recorded together with the lowest value of the bucket 0. Also, the endpoint number represents the bucket number. Once the data is recorded in the bucket, in the column skews, the popular non-values are those that do not occur multiple. Popular non are not fixed and depends on bucket size. Extended matrix, use case with no art. So there is another thing, and this we will cover in another video. So thanks for watching it out. Let's meet in the next video.